Today we're going to look at the normal distribution, which is a graphical representation of the probabilities in any group or population. I have put in here a graph of the normal distribution of heights of 14-year-old girls. When you see that, you can see that it has that normal bell-shaped curve that we're used to seeing and hearing lots about. In these, you will always see that the mean is always the middle of the bottom line, the middle of the curve on the bottom, on your horizontal line. Now, you can tell from that, just by looking at the graph, you can tell straight away that most of the girls are shorter than 1.6 meters, and you can easily say that the average height of a girl is 1.5 meters. Okay, now questions are usually something like, find the probability that a girl picked at random will be less than 1.7 meters tall, and that's written like this: P of X is less than 1.7. Okay, or find the probability that a girl picked at random will be greater than 1.6 meters tall, and that will be P of X is greater than 1.7. So, you need really every piece of data to work that out, and it's a very laborious task. But you can use this normal curve and data. And to use them, you need to do what's called standardizing the data. It's a simple formula, and you'll be doing it later, not now. Now we're sticking with just looking at the graph. But when you do that, your question goes from being P of X is less than something to P of Z is less than something. So when you see the Z, you know that it has been standardized. Okay, and then you can read your answers off your tables and formula book on pages, pages 36 and 37. Here they are. So if you look, you can say that P of Z is less than 1.3. You go to 1.3 here. There's no digits after the 1.3. So it's 0.0932. Or if you want to, what's that extra table doing in there? P of Z greater than or less than 2.14, well then you go to 2.1 over to 4 here, and it's 0.9838. Okay, now we have some rules for reading your Z scores. If you get the probability of Z less than any positive number, you just read it off the tables. If it's greater than the positive number, well then it's 1 minus P of Z less than the positive number. So you're just reading off the number from the tables and taking the answer away from 1. If it's P of Z less than a negative number, then it's 1 minus P of Z less than the positive number. Okay, so you have Z is equal to P of Z less than minus 1.2 is the same as 1 minus P of Z less than 1.2, and that's your answer. Or if P of Z is greater than a negative number, well then it's just the same as P of Z less than the positive number. You can keep going back and referring to these until you learn them, because you have to learn them. So keep going back and checking them. Let's look at an example here. Okay, so assuming that Z is normally distributed with a mean of 0 and a standard deviation 1, find P of Z less than 1.22. That's just straight off the tables. You read it out and you go to 1.22 and you get that. P of Z is greater than 2.37. Okay, so greater than means you have to have 1 minus and turn that sign around. So that becomes 1 minus P of Z less than 2.37. And that's 0.0087. P of Z greater than minus 0.065. That is just the same as P of Z less than the positive value. Okay, so greater than negative is the same as less than positive. And that's 0.7123. And then the last one, which is P of Z less than minus 0.82, and that is 1 minus the positive, which is 1 minus P of Z less than 0.82, and that's going to give you 0.2061. Okay. So then you've got one more thing we have to look at. If you're asking for a probability that something lies between two others, okay? It's like this one here. Find the probability that a number we're looking for is between 0.5 and 1.4. This is like finding shaded areas. It's the same thing. You take the bigger one, find the bigger one, then you find the smaller one, and you take them away. And that's exactly what you do here. Okay, another example. Z has a standard normal distribution. That means it's a standard normal distribution, mean of 0 and standard deviation of 1. Okay, so if the probability that Z lies between minus k and k is that, find the value of k. This is a maths question. It may not look like it, but it's a very maths question. So I'm going to write down, what do I do first? So the first thing I do is I know that it's going to be the probability of this minus the probability of that equals this number here. So that probability stays as it is, but remember, this has a minus number, so that becomes 1 minus the positive. So it's minus, open a bracket, 1 minus my positive probability. Okay, I multiply in my minus now, and so I have that probability there, minus 1 plus, because I'm multiplying in the minus, the probability there. Okay, now if I bring that minus 1 over here, I can add it here, and then I've got P of Z is less than K plus P of Z is less than K. Well, what is that? That's 2 P of Z less than K, and that's equal to 1.1428. Divide both sides by 2, and I get P of Z is less than K is equal to 0.5714. Now I just go to my tables book, up to my tables, and I look at it. What was it again? 5714. 5714. And I start looking. 5714. So that's going to be 0.18. 0.18. Okay. And that's 0.18. So now what I'd like you to do is question 1 of exercise 3.6.